morning, our dear student. Wish you to be the best. And how is it going today? We have been studied in the first lesson in Unit 2 that there are some forms of energy, like potential, like kinetic, like light, and so on. So we studied that one of the form of energy is mechanical energy, and we have been studied that mechanical energy, sum of potential energy and kinetic energy. And we have been taught that the factors effects on the kinetic and potential that effects on kinetic, weight, and height, and that effects of kinetic potential, weight, and height, and the factors effects on kinetic energy are the mass and square of speed of the object, wherever the object is at. Today, we will study lesson 2, that talking about energy transformation. What's meant by energy transformation? Transformation means one form of energy convert into another form. One form of energy convert into another form. Like what? Transformation of energy in the pendulum. We will study transformation of energy in the pendulum and transformation of energy in the simple cell. Number 3, transformation of energy in the electric lamp. Number 4, transformation of energy in the car. Let's study with pendulum. Transformation of energy in the pendulum. Imagine with me that you're pushing a ball of the pendulum with your hand. The potential energy that is stored in it changes into the kinetic energy, and vice versa, without an end. So, the mechanical energy, potential energy, and kinetic energy is still constant. Why? Because when the potential energy convert into the kinetic energy, in the same time kinetic energy return back to potential energy, one of them maximum and the opposite side is minimum. So the energy is constant. Let's do activity. To prove the conservation mean keep the energy. Conservation of mechanical energy of a body that when we push a simple pendulum gently with your hand, then leave it. You will observe that the ball of the moves on both sides around its original position. The speed of the vibrating ball decreased as it was away from its original position, and its maximum when it passes its original position during its movement. Let's see the pendulum. Okay, there are 3 points. 3 points, A, B, and C. In B point, when I push this ball, this ball in its position, the kinetic energy is minimum. Kinetic energy is minimum because we start with potential energy. So the potential energy convert into the kinetic energy. In this way, the ball go and back, go and back, go and back. There is no stable way. There is no point or fixed point. So in this B position, kinetic energy is maximum. Okay. So kinetic energy push itself to, when I push it with my hand, it still go and back to reach to this point, C position. In C position, energy, what is the type of this energy? Kinetic energy. Kinetic energy is minimum. Kinetic energy, why is kinetic energy in C position is minimum? Imagine with me the reaches of the ball to this point, that mean all the kinetic energy well consumed, well consumed, and there is no kinetic energy to move in above the C to be D or F or whatever. So reach to C, and in this point the kinetic energy is minimum. That means the potential energy is maximum. So return back to B. In B, we are calling that in B kinetic energy is maximum. That means potential energy is minimum, and reach to the kinetic energy in this point, the beginning. Okay, what we conclusion from that activity? The explanation: pushing the ball means doing work stored in the ball in form of potential energy. So when you leave the ball, the potential energy changes gradually into kinetic energy. Changes gradually into kinetic energy. So when the ball passes its original position, like B position in this point, well, we observe that its speed is maximum. So kinetic energy is maximum and potential energy is minimum in this point, and there is no stopped of the ball, still moving. So the kinetic energy is maximum and potential energy is minimum. Kinetic energy is zero and the potential energy, when the ball reaches the maximum A and C, its speed is zero. So kinetic energy is zero and potential energy is the maximum. What means that? That means the potential energy and the kinetic energy are exchanged between two poles of the two pendulum, where each of them keeps its mechanical energy value constant. Oh my God, that means potential and kinetic change which each of them to reaches the stable and move and stable, potential to kinetic, kinetic to potential, and so on. We will conclusion from this activity that each moving body keeps its mechanical energy constant, which alternates mean one replace to another and another replace to one. A replace to C and C replace to A between potential energy and kinetic energy, where the increasing the potential energy means decrease in the kinetic energy and vice versa. We can understand from the previous activity that like this. Do you know that our mood like a pendulum tools? Like a pendulum tools? Yes, like this. In A, our mood is zero. Our mood is zero. And after some moving, reach to the high smiling or high happy. So in this point we are happiness, but in this point we are sadness. So our mood like a swing, like a pendulum. In this point, maybe in the medium of feeling, maybe happy, maybe sad. So how do you feel? In this point, I feel happiness, and in this point, I feel sadness. Okay. In this picture, that clear that A, B, C, D, E, F, G. So in G, the ball move from A to B, B to C, C to D, D, E, F, G. So from A is the beginning point that ball will move from it. So the kinetic energy will increase to reach it in D point. In D point, kinetic energy is maximum and potential energy is minimum till to reach the G point. In G point, the kinetic energy, G point potential energy is maximum. We according and we understood that in G, the ball reached to G and return back. That means the maximum of kinetic energy is consuming, decreases to reach the maximum of potential energy and return back. When we look at this picture, this pendulum, from A to G, the ball will move from G to F to E to D to C to B and so on. So in this point, yes, the kinetic energy will increase. No, in this point, in this way, from G to D, the kinetic energy will increase till to reach the maximum point. And still to move and decrease and consuming of kinetic energy, consuming of its energy, the type of kinetic energy to reach to a point. Okay, I want to ask you a question that the motion of the children's swing is like of the pendulum. Why? Because in both of them, the potential and the kinetic energy exchange without an end, and the sum of energies, mechanical energy at any time is constant. Well, alternates mean one of them exchange to another and replace it, and another shape will return back. So when we take a problem that talking about a moving pendulum has a potential energy 0.8 joule at maximum displacement B if the mass of its ball is 0.16 kilogram and acceleration due to the gravity it's 10 meter per second square. Let's solve it. Calculate the height of the pendulum's ball at maximum displacement and the kinetic energy of the ball at such point B. Let's start to solve it. Weight from, we have a mass or a potential energy, and what mass? From the mass, I can obtain a weight. Weight equal mass time acceleration due to the gravity. 0.5 like this time 10 equal 1.6 Newton.